Hi guys, in this session I'll go through the basic configuration on how to set up Virtual Switching Extension or VSX on the Aruba OS-CX platform. To do this I'll be using EVE-NG, which is an emulation piece of software allowing me to spin up a virtual CX switch. In order for you guys to replicate this lab, there are a couple of prerequisites which I'll go through next. Number one is an installed version of EVE-NG. The free community edition will do just fine and you can download that off their website. Number two is an installed version of the Aruba OS-CX image. You can review my previous video where I provide a step-by-step guide on how to set up the image. So let's go over some quick theory before we begin this lab. What is VSX? As mentioned previously, VSX stands for Virtual Switching Extension, and it's a virtualization technology suited for aggregation and core switches. VSX is currently available on Aruba's higher-end platforms such as the 8400 series and 8300 series, with VSF Virtual Switching Framework available on the lower-end models. VSX itself allows two switches to act as a virtualized pair, to function as a single device at layer 2, therefore sharing MAC and ARP tables, and independent devices at layer 3. There are many benefits to this, however to keep this tutorial more concise, I'll mention only a few. You can get a full list of benefits from the Aruba support portal under their technical documents. So some of the benefits include maintaining independent control planes for better resilience, allowing for in-service upgrades to reduce downtime. Having two devices synchronized at layer 2 allows for a loop-free topology when connecting to downstream hosts or devices, providing a quick failover in case a switch or link goes down, and using Active Gateway on interfaces, providing an active-active first hop gateway. Active Gateway itself is an Aruba proprietary technology, although they do support first hop redundancy protocols such as VRRP. However, in this tutorial, we'll implement Active Gateway. The topology we'll use for this lab will look as follows. We'll have two Aruba OS-CX virtual switches acting as a VSX pair, and we'll have a third virtual switch mimicking a host. There'll be a dedicated KEEPALIVE between the VSX pairs and two ISL connections that will form a lag. There'll also be a multi-chassis lag between the VSX pair and the host. The logical topology will require us to configure a number of protocols, including but not limited to the following. We'll configure individual interfaces for the ISL links and associate them with the lag. We'll create layer 3 KEEPALIVE interfaces and associate them with a VRF called KA. We'll set up VSX to form a virtual pair. We'll set up OSPF using a VLAN across the ISL link. We'll create a couple of loopback interfaces, associate some addresses with those, and they'll act as router IDs, and we'll use them for testing. We'll create layer 2, layer 3 VLAN called employee and implement Active Gateway. We'll configure multi-chassis lag on the VSX switches and configure the host. And finally, we'll show a couple of examples of how we can synchronize configuration between the VSX switches to simplify management tasks. I've logged into EVE-NG and set up the lab as per the topology with reference to the physical interfaces and the logical addressing that we'll use. The only configuration I've performed so far is just providing the switches with the host names. Aside from that, there's no configuration on the switches. There we go. So the first thing we'll do is we'll create a lag interface for the ISL. We'll use lag 100 for this, and I'll just copy the configuration across. So we'll get into global configuration mode on both switches, and we'll apply that configuration. So we've given it a description, ISL. We've performed a no shutdown, no routing because it's layer 2, allowing all VLANs across that trunk and set the LACP mode to active. We'll do the exact same thing on the secondary switch. There we go. And next we'll configure the individual interfaces on both switches, so 114 and 115 on both switches to form the ISL, and we'll associate them with lag 100. So I'll just enter those now. So interface 114, description ISL, perform a no shutdown and associate them with lag 100. Both interfaces on both switches. Just to perform some verification commands, what we can do is we can do a show LACP aggregates, and that will show you that interfaces 114 and 115 are associated with lag 100. We can also perform the command show LACP interfaces, and this will give you a bit more detail on how those interfaces are bundled and what state they're in. Next, what we'll do is we'll configure the KEEPALIVE interface 116 on both switches and associate those interfaces with a VRF called KA. So we'll do that now. So we'll create a VRF called KA, KA short for KEEPALIVE, and we'll do the same on the second switch. There we go. We'll get into interface 116 on both switches, and we'll apply the following configuration. So we'll give it a description, KEEPALIVE, we'll attach the VRF to that interface, and we'll give it an IP address 192.168.0.1 for the primary and .2 for the secondary, and we'll perform a no shutdown command on the interfaces. So I'll just configure the secondary interface. Now that we have completed the ISL and KEEPALIVE configuration, we'll move on to the VSX setup. So the way we do that is we go into global configuration mode on both switches. We'll go into VSX, and the first switch, aggregation switch 1, will give that a role of primary, and aggregation switch 2 will give that a role of secondary. Next, what we'll do is we'll configure the interswitch link, which, if you remember, was lag 100, and we'll associate that with the VSX configuration. And we'll do the same on the secondary switch. And finally, we'll associate the KEEPALIVE configuration with the VSX. So the way that works is KEEPALIVE, the peer IP address on the primary is .2 and the source is .1, and we're associating that with the VRF KA. And on the secondary switch, it'll just be the reverse. So the peer will be .1 and the source will be .2, and again associate with VRF KA. And it's as simple as that. So let's perform some verification commands and make sure that VSX has come up as it should have. So we'll run show VSX status. And as you can see, everything's in sync. The local role is primary and the peer is secondary, and on the secondary switch the local role is secondary and the peer is primary. We can also confirm the KEEPALIVE configuration is correct by running the following command, show VSX configuration KEEPALIVE, and that'll show you how the KEEPALIVE is configured for VSX, and we can do the same on the secondary switch. Please join me in part 2, where I'll show you how to configure OSPF, multi-chassis lag, layer 2, layer 3 VLANs, active gateway, and how to reduce your management overhead by synchronizing configurations. If you enjoyed this video, please like, subscribe and hit the bell icon for more upcoming content.